So let's say this graph G is given, and to form or to show the matrix representation of the graph, let me show via different color. So imagine I show it this way. So matrix representation of this graph R is, okay, so it's is the matrix. Since we have 4 vertices, it's a 4 by 4 matrix. So I'm going to have 4 rows and 4 columns. It's a 4 by 4 matrix. And it's going to be effectively each node will have, or each vertex would have one row as a representation and one column as a representation. So I'm going to write them down here. Now, 1 does not have a connection to 1 because there is no self loop on 1. You have 0 here. Maybe I use a different color in the inside for the body of matrix so that it's observable. I'm going to use, say, this color. Okay, so there is nothing. And 1 to 2, there is edge. As you can see, there's in this digraph, there is an edge. So 1 to 2. 1 to 3, there is nothing. There is 3 to 1. So 1 to 3, there is nothing. 1 to 4, there is no connection. So that's it. 2 to 1, as you can see, there is one edge. And 2 to 2, there is no self loop. 2 to 3, there is one edge connection. 2 to 4, there is no connection. And 3 to 1, you can see there is one edge that routes 3 to 1. 3 to 2, there is no edge going from 3 to 2. 3 to 3, there is no self loop on 3. And 3 to 4, there is nothing going from 3 to 4. Finally, 4 to 1, nothing. 4 to 2, nothing. 4 to 3, there is only one edge, so 0, 0, 1. And 4 to 4, there is no self loop. So as expected, this is a 4 by 4 matrix representation of this graph G, so MR or MG, and then you can see that number of ones or non-zero elements seen in this matrix should be exactly equal to number of edges we have. So 5 edges in red, 5 edges in red, there should be 1, 2, 3, 4, 5 non-zero element inside this matrix. That is true. Okay, so this time I'm not going to go and use the intuitive approach in the other video. We're going to find and show this graph that is shown here from previous video using the matrix representation. So matrix representation of, say, G squared. Maybe to avoid confusion, I rename this matrix as well as just simply M of G. So matrix representation of graph G. So M of G squared is just a matrix multiplication of M of G by itself. So M of G, okay, in that case, it will be this matrix 0, 1, 0, 0, 1, 0, 1, 0, 1, 0, 0, 0, and finally 0, 0, 1, 0 multiplied by itself. So 0, 1, 0, 0, 1, 0, 1, 0, 1, 0, 0, 0, and finally 0, 0, 1, 0. Okay, that's a simple matrix multiplication. So the outcome is equal to, using a different color, okay, so the outcome is a 4 by 4 matrix as well, and its first row, obviously, you have to multiply that in matrix multiplication by the first column. If you do that, and we have to do Boolean algebra, so 0, and then times 0, 1 times 1, and 0, 1, 0, 1, so it gives you 1. There is one route, basically. And then you do the same thing first row with the second column. There is nothing overlap, so you get 0. First row with the third column, there is this one overlap with that one, so you're going to get a 1. And finally this with the final column, the fourth column, which gives us 0. Now you repeat the second row with every column, and if you do that, you can see that there is this one overlap with 1, so you're going to get 1. This second row with the second column, because of this one and this one overlap, we're going to get 1. Second row with the third column, there is no overlap, so 0. And finally, second row with fourth column, 0. Third row, first column, there is no overlap. Third row, second column, there is one overlap for ones. And third row, third column, no overlap and no overlap. Finally, fourth row, first column, there is one overlap. fourth row, second column, no overlap, and fourth row and third column, no overlap and no overlap. So the message, the lesson or the outcome learned here is in this 4 by 4 matrix, we have 1, 2, 3, 4, 5, 6. So there should be 6 edges for the G squared, and you can see that is shown here. So the first one, just to highlight it, this one here means in the G squared graph, there should be a connection from node 1 to node 1, so a self loop, and that's this self loop. Okay, and it should be a connection from node 1 to node 3, this one. And you can see that from node 1 to node 3, there is a connection, as it's shown there. And also it shows from node 2 to node 1, there is a connection like this. There you go, this one, 2 to 1. And from 2 to 2, there should be a connection like this, and that's a self loop that is shown here. So, all right, we have this connection, and you can see as we continue doing like this, then we have all the 6 edges, 1, 2, 3, 4, 5, 6, shown on G squared. We can do the same thing following what is written here in terms of how GQ works by cascading another G. So by cascading another G in series with the existing 2G blocks and in the GOG squared operation. So if this is my G squared matrix, all I need to do to find, let me use a different color. So all I need to do to find, and to avoid confusion, let me just go ahead and use the dark, so black. So all I need to do to find the matrix representation for GQ is the matrix representation for G, and then multiplied by multiplying the matrix representation of G squared. Exactly follow the definition of G cube as we see it, GOG squared. So obviously that means G squared, which is this portion, comes first because the input first goes through G squared, and then the output of G squared goes through the third G. This is the same process. So we first process G squared, and then we go to the G. So in this case, we have a matrix for G, which is the first matrix in red. It's going to be 0, 1, 0, 0, 1, 0. So 1, 0, and then 1, 0, 1, 0, 0, 0. Finally, 0, 0, 1, 0. That's for G. And for G squared, we have to copy paste from what we have here. Allow me to use a different color just for a contrast. So for G squared, I'm going to use 1, 0, 1, 0 that we found here, first row, 1, 1, 0, 0, and 0, 1, 0, 0, and finally 1, 0, 0, 0. Okay, so now what we can do is to just wrap up. Let me use, say, for example, this color. Okay, in this case, let me just also move the G squared from here to indicate that this is my matrix G squared. So we know this matrix we are talking about is G squared. Maybe to do it this way. Okay, this is my G squared graph. All right. Now, so what I need to do is I just multiply these. Well, that's not easy to see that color. So maybe I just go with green. Okay, so what I need to do is form this graph now, this matrix, of course, same as usual. So first row matrix, Boolean matrix multiplication by the first column. So as a result of that, we get 1. You continue doing this for the next ones. You get 1, you get 0, you get 0. And for the next one, we're going to get 1. Second row with first column, second row, second column, we're going to get 1. Second row with the third column, we're going to get 1. And second row with the last column, nothing. Third row with first column, going to get 1. Third row with second column, going to nothing. and the third row with the third column 1, and finally 0. And the last column, the fourth row, uh, the fourth row and the first column, you're going to get 0. And then the fourth row and the second column 1. And finally, the fourth row and the third column 0 and 0. So this is the matrix this is the matrix representation for, uh, let me use a different color. So this is the matrix representation for GQ. Let's match. So this means there should be self loop on 1, a connection from 1 to 2, self loop on 1, and a connection. So there you go. This is self loop on 1. This is the connection from 1 to 2 here. And then there should be a connection from 2 to 1. This is the connection from 2 to 1. And there should be, maybe I just highlighted here. So self loop, okay. Maybe the best thing to do is just, let me just redraw this. That's the fastest one. Okay, so I'm gonna redraw this. This was done once using the intuitive approach, but I'm gonna redraw it. So what it means is, if this is, these are the 4 vertices we have, and we are supposed to redraw this G cube. So there is a 1 here, so that means a self loop on 1. There is 1 to 2, so it means go from 1 to 2, and then nothing else. In the second row, we have 2 to 1, so we go from 2 to 1. Okay, and then we have 2 to 2, so that means self loop on 2. Okay, and then we have 2 to 3, so it means from 2 goes to 3, and nothing else. Third row, we have 3 to 1, so from 3 to goes to 1. And then we have 3 to 2, nothing, 3 to 3, so it means a self loop on 3. And finally, what we have is on the fourth row, 4 to 1, nothing, 4 to 2. So we have 4 to 2, and then we have nothing. So that's the important lesson that we have here. Now, you can extend this if you want to also represent the g to the power 4. For g to the power 4, the best thing that we can do is we can repeat the process as shown here. So what I can show you right now is this. Let me just, okay. So what I can show you is this. I'm gonna draw it. So I need to have another g in cascade with g cubed that is shown above. So this, if I do this, this becomes my g to the power 4. And if you do that, then you can write with the same reasoning that matrix representation for g to the power 4 is equal to matrix representation for g multiplying product of that with matrix representation for g cubed. And you have to repeat this whole process. It means copy paste this matrix that we have here. So I'm going to copy paste this matrix for g. Okay, I'm going to copy paste that matrix here, and we need to copy paste the matrix for, say, we need to copy paste the matrix for GQ. Okay, so that would be copy paste this matrix for GQ. Okay, we need to copy paste this matrix, and we're gonna have it here. So we need to find out the product of these two matrices, and then as a result, when we compute that, we end up with finding the connections for the g to the power 4. In this scenario, I have to write it in a compact fashion so that I can accommodate. I can just show it here. Let me see if I can do it. So in this case, what I have is, of course, first row, first column. So I'm going to get 1. First row, second column. Um, I'm going to get 1 as well. First row, third column, going to get 1. First row, last column, nothing. Second row, first column, I'm going to get 1. Second row, and then second column, 1. Second row, and then third column, 1, and nothing. And third row, first column, 1. Third row, second column, 1. Third row, third column, nothing, and nothing. And finally, last row, first column, 1. Last row, second column, 0. Last row, third column, 1, and then nothing. So that's about it. We should have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 edges on, because we have 10 non-zero element in this 4 by 4 matrix representation of g to the power 4. So what we have here is g to the power 4. Let me just write it a little bit higher so that you can see it. But what this matrix that we have here is the matrix for g to the power 4. And in this case, there is not enough space to show, but in a compact fashion, if I want to show it, then the matrix represent, and then the graph for g to the power 4 looks like this. So we have 1, we have node 2, we have node 3, we have node 4. Okay, and connections look like this, just to illustrate what we have on these nodes. So look at the first row. It means 1 to 1, 1 to 2, 1 to 3. So there should be a self loop on 1, and it should be 1 to 2, and then it should be 1 to 3. Okay, and then we have um, second row, 2 to 1, 2 to 2, 2 to 3. So self loop on 2, to return path to 1, and also we should have 2 to 3. Let me follow the same procedure in terms of naming. So let me just do it this way. Okay, all right. Meaning, okay, meaning I have to name 3 this way. And maybe the best thing is I just have a little bit more space here. So I would say I put 1 here. I put, let me put 1 here. So 1, and then 2, and then 3, and then 4. Okay, so with this scheme, now I think I have good enough spacing. So there should be a self loop on 1 as we discussed. Okay, there should be a connection from 1 to 2. There should be connection from 1 to 3. So let me name this 3 again. So let me name this 3. Okay, I'm trying to just follow the same placement for the nodes as we had for the previous powers. That's why I am a little bit hesitating. So 1 to 1, 1 to 2, and then 1 to 3. And then we have 2 to 2, 2 to 1. And then we have 2 to 3. And then for the third row, we have 3 to 1, 3 to 2. So 3 goes back to 1, and then 3 goes back to 2. So, and then finally for the fourth one, we have 4 to 1, 4 to 3. So 4 goes to 1, and 4 goes to 3. So you can see that we have effectively, as shown here, we have 10 edges that are shown here corresponding to 10 non-zero element inside the matrix, and this is the matrix, this is the graph representation of g to the power 4. All right, so I hope that this, in combination with the previous video that intuitively found the graph for g squared, g cubed, and g4, which means the graph powers for this simple graph g that is shown here, I hope that this matrix method of finding the graph connections and edges, and also the previous intuitive method of not using the matrix but just following the input-output procedure for the graph is helpful and are helpful in terms of understanding how to deal with the graph powers.